So, in this video, we're going to just talk about how to write and balance acid-base neutralization reactions. So, let's take a look at an example. Let's say you have hydrochloric acid and you're reacting it with a base like, let's make the base NH3, okay? So, since HCl is an acid, it's going to, donate a proton. And since NH3 is a base, it's going to accept that proton. So all you got to do is simply write the NH3, you add the proton to the NH3, which gives you NH4. And since the proton comes with a positive charge, you add a little positive charge on top out there. And then you write the conjugate base of the acid, which is basically HCl without the H plus, which is Cl minus. So there's your um, writing an acid-base neutralization reaction. And the reason it's called a neutralization is because we basically say that acids react with bases to neutralize them. Simple as that. That's why an acid-base reaction is pretty much also called a neutralization reaction. Okay, so now that we understand that, let's take a look at um, you know a few more different types of acid-base reactions. And Number one, we're gonna write the neutralization reaction, but then number two, we're gonna also balance the reaction. So let's take a look at HCl plus NaOH. As you can see, this NaOH is a different type of base, where the OH minus is basically the basic part of the base. So when you write this, the key out here is to isolate. I'm gonna show you with a different color. Take the H off the acid and then the OH off the base and just write that separately out here. So that becomes H2O. Okay. And then switching back to a regular color, we're gonna just put the NaCl together. That's NaCl plus H2O. So as you can see, the acidic part, which was this part of the acid, and the basic part of the other molecule, they combined to form water, which was the neutralization reaction, and then you ended up with a salt. So now if you take a look in terms of if the reaction is balanced or not, you have one sodium on the left, you have two hydrogens on the left, one from here and one on the OH, you have one oxygen, and then you have one chlorine. If you look on the right hand side, you have one sodium, two hydrogens, one oxygen, and then one chlorine. Okay, so this reaction, we didn't really have to do much other than simply, react the acid and the base to get a neutralization reaction. And then we basically wrote out the products, and turns out it was balanced. Let's look at one which is a little more difficult than the one above. So let's say you still have the same acid, HCl. This time, instead of reacting it with sodium hydroxide, we're going to react it with calcium hydroxide, which has a formula like this. We do the same thing like we did before. We take the H, we combine it with the OH, and we actually end up getting H2O. And then we're going to write the remaining calcium and chlorine by itself. But it's important to understand that calcium actually, if you split the calcium hydroxide, you will see that calcium actually has two positive charges over it, whereas the OH minus and the OH minus only has one negative charge. So therefore, if we assume those two positive charges on the calcium are there, if you and it's simple. It's combining with chlorine, which only has one negative charge on it. Therefore, using the crossover rule, okay, the actual formula for calcium chloride should be CaCl2. So let's rewrite this equation. So we have HCl plus CaOH twice gives us CaCl2 plus H2O. Okay. So now that we have this, let's take a look and see if it's balanced or not, because the neutralization part is done. Okay. So we have, oops, sorry. We have one chlorine on the left, two on the right hand side. It turns out we can simply put a 2 out here in front of the HCl. If you remember, when you balance, you can only add coefficients. So 2 in front of the HCl balances the chlorines, but then the 2 in front of the HCl also makes the hydrogens twice the amount. But if you take these hydrogens on the left, on the HCl, and another 2 hydrogens from the calcium hydroxide, that gives you a net of 4 hydrogens. So you have to put a 2 in front of the water out here to make that 4 hydrogens. Consequently, now you see the oxygens became 2, and you have 2 oxygens out here, calcium hydroxide. The calciums are the same on both sides, and this whole equation is balanced.